Okay, use the graph of y is equal to h of x to determine each of the following. A, limit as x approaches -1 to the left side of h of x. And okay, so starting with part A, -1 here is right, it's located there. If you're approaching from the left side, then we're basically we're approaching -1 from the left, so it could be like -1.0001, right? You can actually notice that if you follow the trace here, this is actually going to be, y is going to approach +1, right? So limit as x approaches -1 from the left side of h of x will approach +1, right? Part B here, limit as x approaches -1 from the right side of h of x. If you look at approaching it from the right side of h of x, now you can notice here that we actually will shift gears. We're going this way now. We're approaching 1 from the right side, and we actually get to a point discontinuity. This actually doesn't exist. Okay, so you can imagine that the left and right-handed limits aren't the same. So this already tells us that there's a discontinuity, and this is really common of what we call a jump discontinuity, and this is something that you would see in a piecewise function. So this actually is a piecewise function. And a piecewise function is basically a function that has multiple functions at different intervals, right? So you can see that from -∞ to -1, it looks like a quadratic, but then from -1 to 3, we have a linear portion, and then we have another quadratic portion from 3, right? So let's take a look at part C, right? Limit as x approaches -1 of h of x. So at -1, we can notice here that you have basically a point that doesn't exist, and we have a point that does exist. It's equal to the point that does exist, which is basically 1, right? But because the left and right-hand limits don't equal each other, then the point is discontinuous at x is -1, right? So it's discontinuous, right? And it's because the left and right-hand limits, limit as x approaches -1 from the left side of h of x is not equal to the limit as x approaches -1 from the right side of h of x. Okay, h of -1 does exist, however. The point here is equal to 1, right? But the left and right-hand limits will make the point discontinuous. Okay, now let's take a look at the second part. So there's another point, series of points that we're going to be looking at. We're going to look at continuity at x approaches 3, right? So limit as x approaches 3 from the left side of h of x. So if we're looking at 3 from the left side, so this is 3, we're approaching from the left side, we're approaching it this way. So a value from the left of 3 could be like 2.99. And you can actually see that it gets closer and closer to 2. Then for part F, limit as x approaches 3 from the right side of h of x. We're looking at the right side. I'm just going to switch colors here. Let's use orange. If we're looking at the right side of h of x, you can see that it gets closer and closer to the whole. The point discontinuity, so it doesn't exist. So because these two limits don't exist, then we can understand that the point itself is discontinuous, right? For part G here, limit as x approaches 3 from h of x, we can see that the point 3 exists, it's 2, and h of 3 is equal to 2, right? So therefore, limit as x approaches 3 from the left side of h of x is not equal to the limit as x approaches 3 from the right side of h of x. So x is equal to 3 is discontinuous. So this also implies a jump discontinuity. So you can notice that jump discontinuities occur when the left and right-handed limits aren't equal to each other.